It happened almost overnight, an event that would send shockwaves through the global tech community and rewrite the rules of the semiconductor industry. Chinese scientists announced a stunning leap in two-dimensional chip manufacturing, revealing a breakthrough that many thought was still years, if not decades, away. The news raced around the globe, stirring excitement, disbelief, and honestly, a bit of fear among competitors and industry leaders. Headlines blared, and social media buzzed as experts scrambled to understand the implications. For years, experts said making chips from two-dimensional materials at large scale was, well, impossible. The challenges were immense. Fragile materials, complex processes, and the need for absolute precision. Suddenly, it isn't. China has shattered that barrier, opening the door to a new era in chip technology. The chip war has changed, and China is now at the center of it. This breakthrough has shifted the global landscape, putting China in a position of unprecedented influence over the future of electronics. This isn't just another lab demo or small sample. Researchers in China have produced big, clean sheets of a powerful new material, setting a world record for size and purity. These sheets are the foundation for next-generation chips, and their scale means real-world applications are now within reach. They used a new technology, one that combines advanced robotics, precision chemistry, and innovative engineering, to make this process fast, reliable, and incredibly precise. The speed and quality of their results have shocked even industry insiders who thought such progress was still far off. This is no small thing. Chips made from these materials could be the future of electronics, computers, and even artificial intelligence. Imagine faster, more energy-efficient devices, smarter AI, and breakthroughs in everything from smartphones to supercomputers. The possibilities are staggering. Before this, the West was leading in chip technology, with companies in the US, Europe, and Taiwan setting the pace. Now, China's move throws everything into question, challenging the established order and forcing rivals to rethink their strategies. The balance of technology power may be shifting, and the world is watching closely. Investors, governments, and tech giants are all scrambling to assess what this means for the future of the industry and for global competition. How did China do it, and what does it mean for all of us? Let's break down the story, step by step, and see just how big this news really is. The answers could shape the next decade of technology, and the world as we know it. Making computer chips is already very hard. It's a process that requires extreme precision, advanced technology, and a level of cleanliness that's almost unimaginable. Even the tiniest mistake can ruin months of work and millions of dollars in investment. But making chips from two-dimensional materials, which are only one atom thick, is even harder. These materials, like graphene or molybdenum disulfide, are so thin that they're almost invisible to the naked eye. Working with them is like trying to build a skyscraper out of sheets of tissue paper, except the tissue paper is 1,000,000 times thinner. Imagine trying to spread a single sheet of paper perfectly flat, with no wrinkles, over a soccer field. That's how tough it is to make big, clean sheets of two-dimensional chip material. Any tiny bump, wrinkle, or speck of dust can ruin the entire sheet. And unlike regular paper, you can't just smooth it out with your hands. The process requires specialized tools and an environment cleaner than an operating room. Scientists have wanted to use two-dimensional materials for years because they could make chips faster and more efficient. These materials have unique electrical properties that could lead to computers that are not only faster, but also use less power and generate less heat. The potential for revolutionizing electronics is enormous. But until now, they could only make tiny samples in the lab. These samples were too small, too dirty, or too broken to use in real factories. Researchers could demonstrate the amazing properties of these materials on a microscopic scale, but scaling up to something useful for industry was a different story. Scaling up from the lab to the factory was a wall nobody could climb. Factories need wafers that are large, smooth, and clean for mass production. The transition from a few millimeters in a lab to a full-sized wafer in a factory setting is a leap that has stumped scientists for years. Any small mistake, like a tiny speck of dust or a crack, can ruin the whole chip. In traditional chip making, even a single particle can cause a defect that makes the chip unusable. With two-dimensional materials, the risk is even higher because the material is so fragile and sensitive. For two-dimensional materials, this is a huge challenge. Making a few square centimeters is hard. Making a whole wafer is almost impossible. The process is painstaking, and the yield, the number of usable chips you get from each batch, has been extremely low. This has kept two-dimensional chips out of mainstream production, despite their promise. That's why the news from China matters so much. They've figured out how to make these big, perfect wafers. For the first time, it looks like two-dimensional materials could be produced at the scale needed for real-world chips. The chip world is taking notice, and this breakthrough could open the door to a new era of faster, more efficient electronics, changing the future of technology as we know it. The material at the center of this breakthrough is called molybdenum disulfide, or MOS2. It sounds complicated, but it's basically a very thin crystal, just a few atoms thick. Scientists have dreamed of using MOS2 because it can do things silicon, the old material, can't. MOS2 is a type of two-dimensional semiconductor. That means it can control electricity in new, powerful ways. It lets engineers make transistors, the building blocks of chips, smaller, faster, and more energy efficient. In theory, using MOS2 could lead to computers and phones that are much quicker and use less power. But there's a catch. Making MOS2 in the lab is one thing, making it into huge factory-ready wafers is another. In the past, when scientists tried to make bigger pieces, the MOS2 would break, twist, or get dirty. This ruined any hope of mass-producing chips from it. MOS2 is precious in the chip world. Whoever figures out how to mass-produce it could control the future of electronics. To solve the problem, Chinese scientists created a new method called oxy-MOCVD. It's a special way to grow MOS2 crystals, using a mix of oxygen and other gases. MOCVD stands for metal organic chemical vapor deposition. Adding oxygen, the oxy part, changed everything. In this process, scientists put a wafer inside a chamber. They heat it up and let special gases flow over it. These gases carry the ingredients for MOS2. When they touch the hot surface, they react and form a perfect thin layer. The oxygen helps keep everything clean and stops unwanted reactions. What's special about oxy-MOCVD is how fast and clean it is. The process can make a large, uniform sheet of MOS2 in just 20 minutes. The wafers are smooth, with almost no defects and very few impurities. This is a huge improvement over older methods. Thanks to oxy-MOCVD, Chinese labs can now make factory-scale wafers that are ready for real chip manufacturing. Before oxy-MOCVD came onto the scene, scientists had to rely on older, less efficient methods to make MOS2. The most common techniques were chemical vapor deposition, often called CVD, and sputtering. These processes were the backbone of early semiconductor manufacturing, and while they were groundbreaking in their time, they had some serious limitations that held the industry back. These older methods were, honestly, pretty slow and messy. The equipment was complicated, and the process required a lot of manual intervention. Chemical residues would build up on benches and machines, making the environment difficult to keep clean and increasing the risk of contamination. The results weren't great either. The crystals that formed on the wafers were often small, patchy, and uneven. Instead of growing together smoothly, they would form isolated islands, leading to weak spots and poor electrical performance. Even after hours, sometimes an entire day, of careful work, the finished wafers were riddled with cracks, dust, and other defects. These imperfections made the wafers unreliable and unsuitable for high-performance chips. Making a wafer the size of a dinner plate could take a whole day, and even then, the end product was often warped or full of flaws. This slow pace and low yield made it nearly impossible to meet the growing demand for advanced chips. Factories need to produce thousands of wafers, quickly and consistently. But with these slow, unreliable methods, keeping up with demand was a constant struggle. Workers were frustrated, and companies lost valuable time and resources. That's why for decades, the chip industry has been stuck using silicon. Silicon was easier to process with these old techniques, even if it wasn't always the best material for the job. But then, oxy-MOCVD arrived and really changed the game. This new method brought a level of precision and efficiency that was simply not possible before. With oxy-MOCVD, scientists can now make a large, clean wafer in less than half an hour, a fraction of the time it used to take. The process is streamlined and highly automated, reducing the risk of human error. The wafers produced are almost perfect, with less than one defect per 10,000 square microns. This level of quality is unprecedented and means that chips can be made smaller, faster, and more reliable than ever before. In fact, this is a new record for the industry. It's a milestone that sets a new standard for what's possible in chip manufacturing. The process is also much easier to control. With user-friendly interfaces and automated systems, factories can adopt oxy-MOCVD quickly, without the steep learning curve of older methods. Now, China has the tools to scale up production at an unprecedented rate, leaving behind the old problems of slow, messy, and unreliable wafer manufacturing. This breakthrough is paving the way for a new era in the global chip industry. China's progress isn't just about making big wafers. Other teams are also making breakthroughs. For example, some scientists have found ways to watch the MOS2 crystals grow in real time. They use special microscopes to see atoms moving and joining together, giving them control over the whole process. This real-time observation means they can adjust the conditions instantly, making the growth even cleaner and more uniform. It's kind of like watching a plant grow, but at the atomic level. Any mistake can be fixed right away. Other groups have focused on batch production. They showed it's possible to make many big wafers at once, not just one. This is a huge step for real-world manufacturing. Factories need to make hundreds of wafers every day, so batch production is key. All these breakthroughs are pushing the 2D chip field forward, faster than anyone expected. Making big wafers is just the first step. Can you actually build real working chips from these materials? The answer now is yes. Chinese teams have already created microprocessors, tiny computers, using 2D materials like MOS2. These chips can run code and do simple tasks. This is a huge milestone. A microprocessor is the brain of computers and phones. Making one from 2D materials proves the technology works, not just in theory, but in practice. The chips are small and efficient, showing the real-world promise of the new materials. The next step is scaling up. If these microprocessors can be made in large numbers, China could start making 2D chips for everything from smartphones to data centers. This could change the industry forever. For now, the world is watching closely, waiting for the next big leap. These breakthroughs didn't happen by accident. They are the result of teamwork across many of China's top universities. Schools like Tsinghua University, Fudan University, and the University of Science and Technology of China are all working together. Each group focuses on a different part of the problem. Some work on making better wafers, others study how atoms move and crystals grow, still others build working processors from the new materials. By sharing ideas and results, they speed up progress for everyone. This level of coordination is rare. In the past, universities and labs often worked alone or even competed, but in China, they are uniting to reach a common goal, winning the 2D chip race. This teamwork is helping China move faster than anyone thought possible. So, why does all this matter? The answer is simple. The chip industry is the heart of modern technology. Whoever leads in chips leads in everything: AI, defense, smartphones, and more. China's new breakthroughs mean it could leap ahead in the race for the most advanced chips. 2D materials, like MOS2, could make computers faster, smaller, and more energy efficient. They could unlock new types of technology we haven't even imagined yet. This isn't just a technical change, it's a shift in global power. The world is now facing a new chapter in the chip war. Will China's 2D chip factories outpace the West? What will it mean for your phone or your country's security? The answers aren't clear yet, but one thing is certain. The race has changed forever. As we watch the future unfold, it's time to ask, how will 2D chips shape the world we live in next?